Welcome to The Explainer. Okay, today we're doing something a little different. We're stepping away from looking at isolated climate events, and instead we're diving straight into the mechanics of a planetary chain reaction. We're going to explore a really fascinating story about environmental domino effects. Basically, how the failure of one massive system on Earth can directly trigger the collapse of another. It's kind of terrifying, right? But also totally fascinating. What actually happens when the Earth's safety nets just start to break? Usually when we hear about global warming, we hear about things happening in total isolation. A heat wave over here, a melting glacier over there. But our planet isn't just a collection of separate puzzle pieces. It's a deeply, deeply interconnected web. And network science tells us that when one crucial node in a network fails, the shockwaves absolutely do not stop there. They ripple outwards. All right, let's dive right into this by defining the core mechanism behind these global shocks, the tipping point. In complex system science, a tipping point isn't just things getting steadily worse day by day. It's a critical threshold. Once you cross it, a system undergoes a transformation that literally feeds on itself and, crucially, becomes irreversible on human timescales. Think of it like pushing a boulder up a hill. The tipping point is that exact moment it rolls over the crest and starts tumbling down the other side. You can stop pushing, but guess what? That boulder's going to keep rolling anyway. Take this global map from recent Earth system dynamics research, for example. It beautifully and maybe a little frighteningly illustrates how the Earth isn't just a bunch of isolated environments. We're looking at massive continent-sized subsystems, like ice sheets and ocean currents, and the physical, chemical, and biological linkages that connect them all together. A change in the Arctic doesn't just stay in the Arctic. It sends a destabilizing signal right down the Atlantic Ocean. So scientists actually categorize these planetary chain reactions into three main types. First, there's the two-phase cascade, where rising temperatures cause systems to tip one after another independently. Then there's the joint cascade, where two geographically connected systems just fall together at the same time. But for this explainer, we're zeroing in on the most dramatic, consequential pattern of them all, the domino cascade. This is where the collapse of System A physically reaches out and knocks over System B. To really wrap your head around the reality of this, listen to this quote from glaciologist Ian Howitt. He notes that we aren't just dealing with a single point of failure anymore. He says, and I quote, "It's more of a staircase where we've fallen off the first step, but there's many more steps to go down into the pit." Basically, we've already knocked that first domino over. Now we're just watching the momentum travel down the line. Now, before we trace out that exact path, there's a really vital framework from researchers at MIT we need to keep in mind. When we talk about tipping points and feedback loops, it's super easy to picture a sudden on-off switch, like boom, the world changes overnight. But it's actually much more like a dimmer switch. Every fraction of a degree of warming turns that dial up, causing more ice to melt, more permafrost to thaw, and accelerating the whole domino effect. The speed of the cascade is directly tied to exactly how far we turn that switch. Okay. So what does this specific domino path actually look like? Well, it plays out in three main steps. First, the Greenland ice sheet melts, dumping massive amounts of fresh water into the ocean. Second, that disrupts and weakens the AMO ocean conveyor belt. And third, because of that changing ocean current, global rainfall patterns shift, directly drying out the Amazon rainforest. Let's start with domino 1, melting ice and thawing Earth. 7 meters. That is roughly 23 feet. Just picture that for a second. That is the sheer amount of potential global sea level rise locked up right now in the Greenland ice sheet. And researchers at Ohio State University have found that we may have actually already crossed its tipping point. The snowfall that normally replenishes those glaciers, it just can no longer keep up with the pace of the melt. The ice dynamics have essentially been knocked into a constant state of loss, which means even if temperatures magically stopped rising today, that ice would likely continue to shrink. Now, what's really interesting here is how these huge tipping elements literally mirror each other. As Greenland sheds its ice, the neighboring Arctic permafrost is thawing out. Permafrost is this permanently frozen ground that has trapped dead plant matter for thousands and thousands of years. But as that top layer thaws, microbes wake up, they start eating that ancient plant matter, and they release massive amounts of carbon dioxide and methane. And much like Greenland, as the Amazon loses its resilience, downstream, it also risks flipping from a system that protects us into one that actively harms us. To put that permafrost thaw into perspective, the latest UN climate models project that permafrost could release up to 240 gigatons of carbon this century. 240 gigatons. That's equivalent to more than 2 entire decades of our current global fossil fuel emissions. It acts as this massive threat multiplier. It just cranks the heat up on our dimmer switch, pushing the next domino over even faster.
Moving right along to Domino 2, the ocean's conveyor belt.
So where does all that melting Greenland ice actually go? Straight into the Atlantic Ocean. Underneath those stormy waves is a massive current called the Atlantic Meridional Overturning Circulation, or the AMOC for short. Think of it as this gigantic global conveyor belt. It pulls warm, salty water from the tropics all the way up to the north. Once it's there, the water cools down, gets heavy and dense, and sinks right to the bottom before flowing back south. But remember all that fresh water pouring off Greenland? Well, fresh water is light and buoyant. It dilutes the heavy, salty water, essentially jamming the gears of this conveyor belt and stopping that crucial sinking process.
Because of this massive jam, the AMOC is currently at its absolute weakest point in 1,600 years. Now, just to look at the science completely impartially here, 34 state-of-the-art climate models recently found that a sudden, Hollywood-style total collapse of this current, that's unlikely to happen this century. However, a severe weakening, like slowing down by 20 to 80%, is highly probable. And the scary reality is we don't even need a total collapse for disaster to strike. As Dr. Aksu Hu from the Global Climate Dynamics Laboratory points out, even just a 50% reduction in this current fundamentally alters heat transport across the entire globe. Without that warm water moving north, temperatures in Europe would absolutely plunge. Sea levels on the U.S. East Coast would rapidly rise. But perhaps the most devastating part? It would dramatically shift global monsoon systems, severely disrupting the rains that literally billions of people rely on. Which brings us right to Domino 3, the Amazon's edge. Let's see how this all connects. Slower ocean currents literally change where rain falls globally, directly striking the lungs of our planet in South America. You see, the Amazon rainforest actually creates half of its own rainfall by recycling moisture through its trees in these massive flying rivers. But the forest is facing a really dangerous dual threat right now. Global heating is reducing the incoming rain from the ocean, while direct human deforestation is cutting down the very trees that recycle whatever water is left. Scientists estimate that if we clear just 20 to 25% of the forest, the entire system loses so much moisture that it can no longer sustain itself. And currently, we're sitting at about 18% cleared. Brazilian climate scientist Carlos Nobre, who has dedicated 3 decades of his life to studying this exact threshold, warns that we are, quote, perilously close to a point of no return. The dry season in the southern Amazon is already up to 5 weeks longer than it used to be. Tree mortality is just skyrocketing because the forest simply doesn't have the water it desperately needs to survive these lengthening dry spells. So if the Amazon does tip, it experiences what we call a dieback. It wouldn't just poof, vanish overnight. It would rapidly transform into a degraded, dry savanna. We could lose 50 to 70% of the forest cover entirely. This die-off would release a staggering 200 to 250 billion tons of carbon dioxide back into our atmosphere, making it practically impossible to hit global climate targets. Plus, the loss of those flying rivers of moisture would slash rainfall in key South American agricultural basins by over 40%. Okay, so why does this actually matter to you and me? Because at the end of the day, a cascade isn't just some abstract scientific math problem. When these dominoes fall, they land squarely on the foundations of human civilization. Melting ice swallows coastal cities where millions of us live. Shifting ocean currents and dying rainforests completely shatter global food security, drying out the agricultural basins that feed billions of people. It amplifies extreme weather right outside your front door. Finally, let's talk about halting the chain reaction. The good news here? This story is absolutely not over. Because we actually understand the physics of these falling dominoes, which means we know exactly how to stop them. The answer brings us right back to that dimmer switch analogy from earlier. Because all these systems are inextricably linked to temperature, every single fraction of a degree of warming that we prevent acts as a wedge, stopping that next domino. Transitioning to cleaner energy sources and halting unsustainable logging directly keeps the Arctic permafrost frozen, and it keeps that vital moisture recycling through the Amazon. It slows the entire cascade down, giving humanity the most precious resource of all, the time we need to prepare, adapt, and restore. Look, we have undoubtedly knocked over that first domino. We've fallen off the first step of the staircase, but the complete cascading collapse of our Earth's vital systems, that is not locked in yet. The science is incredibly clear on the mechanics of the chain reaction, But the ultimate outcome? Well, that depends entirely on how quickly we act to stabilize the board right now. So the question I'll leave you with is this. Are we gonna let the rest of those dominoes fall? Thanks so much for joining me on this explainer, and remember to always keep questioning the world around you.